Okay, so let's go back to real-time mode for a second. And let's go back to PC0, left click on it. And if I go back to the command prompt, looks like we're already here. So how did we get here? I left click on the PC0, go to command prompt, and go here, and I will type ARP-A. I want to see that ARP record. Look at that. Now this PC knows exactly where the MAC address of the PC1. So 192.168.1.2, it's keeping track of it. Its MAC address is this. So next time when it wants to communicate with PC1, it doesn't have to send that broadcast to find it anymore, that ARP, that address resolution protocol, that using the broadcast IP in the segment, or the IP segment. So what do we know now? We know about address resolution protocol and how it's used. PCs use it when they don't know the MAC address of another PC. So they send a broadcast to resolve the issue of not knowing who they want to communicate with initially. The broadcast goes to the switch. The switch says, okay, this is a broadcast. I'm going to send it to all ports except where it came from. One of the devices on the network will respond if it knows. And when it responds, and this PC now knows the MAC address of that IP address, unicast communication starts to happen. So private conversation will happen. Initially, it was just trying to find. If you're trying to find someone, it doesn't make it private. It says, hey, I need to find you. Once I find you, we can have a private conversation. Okay? So let's now look at PC1. Does PC1 have PC0's IP address and MAC address on its MAC address table? Its ARP table, command prompt. Let's go to command prompt. Let's type ARP-A, and there it is. It also knows PC0's MAC address and IP address. So if it wants to talk to PC0, it doesn't have to send a broadcast. It doesn't have to let everybody know that it wants to have a private conversation. Let's put that to the test. Go back to simulation. Make sure you only have ARP and ICMP selected, and let's send a ping. So I'm going to go back to PC1, say ping, and remember destination is where you want to send the ping to, 192.168.1.1. Enter. That envelope. Go back down. Hit play, and will it send a broadcast? No, it will not. It will send a unicast. It's a private conversation. The switch says, oh yeah, I know where to send this. I know the MAC address of this device. And this one, the responder says, the switch says, oh yeah, I know where to send it. I know the MAC address to the port of this device. So it always knows the port and the MAC address. Green check mark. Good to go. Let's go back to real-time mode. Click real-time. Okay, but what about these? Do they know anything? Left click. Go to command prompt. ARP-A. No ARP entries found. Let's go to PC2. Command prompt. ARP-A. No ARP entries found. So if these two devices, close this, PC2 and PC3 want to start communicating with any one of these, they will also send a broadcast to find out initially, because they don't know the MAC address, because the switch only deals with MAC addresses. The switch says, who do you want to talk to? You say, I don't know. Then a broadcast happens because you have the IP address. The switch will say, okay, you want me to send this thing. I don't know what it is. I don't know. You call it IP, whatnot. I don't deal with IPs. But I will forward it. Whoever knows about IPs can respond to you. And when you get the MAC address, talk to me. I'll check my records. So let's look at that once more. So I'm gonna have PC3 try to talk to PC1. Let's say so PC3 and PC1. All right, back to simulation mode. Left click on PC3. Go to command prompt. Ping 192.168.1.2. Okay, I'm going to minimize this and go and hit play so that the interaction can happen. Wait a minute. Broadcast happening right now. Boom. Megaphone. Timmy, are you there? These people are not Timmy. Here we go. Timmy responds. Switch says, I don't know what the ping this MAC IP business is, but when you get the MAC address, PC says, oh, I know the MAC address now. Here's the MAC address. I only want to talk to this PC, and now it's unicast, one-to-one private conversation. Okay, so what do we now know? The switch deals with its MAC address table to send messages privately. Each device connected will send a message based on what's in its ARP table, address resolution protocol table. If they have a matching MAC address, it will go to that PC. If it doesn't, it will send a broadcast to the switch saying, hey, I don't know the MAC address. Can you help me find it? I have this IP address thing. The switch says, I don't deal with IP addresses, but I'll send it. I'll send a broadcast on my megaphone and try to find you, whoever has this. And if one of these PCs has it, a message is sent back from that PC to the PC that made the request. And after that, that PC will send a message to the switch saying, hey, I'm looking for this. I want to talk to this MAC address. And the PC will make sure the conversation is, the switch will make sure the conversation is private. Okay, so what about a router? What about a router? Does the router also have an ARP table? Because the router is layer 3. So the switch is layer 2. Layer 2 is, on the OSI model, is called data link layer. If I go to simulation mode and I run that ping again, we're going to see an example of all the different layers. Let me hit play, and I will go here and open this, and here we are, the OSI model, different layers. So at the top says OSI model. We have layer 1, layer 2, layer 3. Now notice layer 3 is blank. We are not touching IP. This is all layer 2. MAC addresses is layer 2. That's where they live. That's where the logic for layer 2 is. Switches handle communication back and forth with MAC addresses, not IP addresses. But PCs communicate with both MAC addresses and IP addresses. If it's a layer 2 message, if it's a device on its same network, it will send it on layer 2, the MAC address. The switch will figure it out. But if it's a device that is not on its network, it usually will try to send it to its default gateway, which is an IP to layer 3. What lives on layer 3? The router lives on layer 3. It handles IP addresses, packets. So if I add a router here, routers are similar to, so I'm going to go back to real time. Routers are similar to PCs. I'm going to go to network devices, and I'll pick a 2911 router. I'll place it down here. It's similar to the PCs in the sense that they will also keep an ARP table. So I will connect it to port 5 on G00. I'm going to left click on the router. Oops, sorry. Let's keep this real. Let's keep it real, as realistic as possible. So I will move my console cable from here. And let me just delete it. I'm going to go up here, click on this X, delete the console cable, go back to my selection tool in the top left. Okay, go back to connections down here, select console, left click on the laptop, RS-232, left click on the router, go to the console, and here I'm going to left click on the laptop, close the terminal window, reopen the terminal window, click OK, and here we are, we're on this new router, not configured. I'm going to say N for no for this initial message, press enter, enable to get out of privileged user mode, and I'm going to pause and we'll explore the router in the next video.